A very hearty good evening to all our participants in this 30th Weekend Talk organized by Center of Excellence in Safety Engineering and Analytics, IIT Kharagpur. And this program is conducted under Azadi Ka Amrit Mahotsav, which commemorates 75 years of India's independence under the government of India. So we initiate our weekend talk with this wonderful shloka, Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityorma Amritam Gamaya, which inspires us to lead from ignorance to the truth, from darkness to the light, and from death to immortality. With this, myself, Mom Mitra from Tata Steel, along with our co-moderators, Sovik and Ashish and Sween from IIT Kharagpur, welcome once again all of you to this wonderful weekend talk. Today we have with us our expert speaker, Dr. G. Madhu, who is a professor in the Division of Safety and Fire and Engineering and also professor and head of the Division of Chemical Engineering at the School of Engineering, QSAT. He was formerly the principal of the School of Engineering of QSAT, Dean of Engineering of QSAT, head of the Division of Safety and Fire Engineering in various tenures. He has served as a chairman in the Ernakulam District Environment Committee constituted by the Kerala State Pollution Control Board during 2006 to 2012. Since 2015, he has been serving as the chairman of QSAT Board of Studies in Chemical Engineering, Safety and Fire Engineering, and as a member of Academic Council, Faculty of Engineering and Faculty of Environmental Studies at QSAT. He has worked with FACT Limited, Udyoga Mandal Coaching in various capacities from January 1986 to June 2004. He has more than 18 years of industrial experience in plant operation, process design, environmental protection, and process safety, and has completed several assignments on hazard identification and risk assessment studies, environmental impact assessments, and safety audits. He was awarded from Professor K.M. Bahauddin Award 2018 for the Distinguished Engineering Teacher of Kerala, instituted by the NIT Calicut Alumni Association. For meritorious services to chemical and safety engineering, he also received the Platinum Jubilee Award of the Institution of Engineers and the Karnataka State Center for the meritorious services to chemical and safety engineering. So the list is endless for for Dr. G. Madhu, and I think the audience is very privileged to have him, to hear him on the topic of recent trends in safety and sustainability of chemical process plants. So with this, sir, we welcome you to this weekend talk, and I request Dr. Obi Krishna, our convener of the Weekend Talk series, to formally welcome our expert speaker.
Thank you, Mom. Professor Madhu, very happy to see you. And after many years, we are again in touch with you. We are very fortunate to have a speaker like Professor Madhu, who is the HOD of Chemical Engineering, and he is the professor of safety and fire. So normally the chemical engineering people are one of the good resources for safety and fire. So that's why you are a great resource to us. We are very thankful to you for you accepting this our invitation and speaking on this. And your credibility, I can see you have guided more than 30 PhD scholars, and you have 100 MTech dissertations. Your HNDX is 8. It's a great, you're academically very sound. And you're associated with many industries, I know. At this point, I should also thank QSET for giving to Tata Steel. When I was in Tata Steel, about say 10-12 years back, first time we wanted to go for campus selection for safety engineers. Then we have shortlisted QSET, and we have come and taken certain students, and they have proved very well. They performed very well. So we are very thankful to you for giving good resources to the industries. I'm very happy. One of your students who worked here in Tata Steel again joined back as a faculty. That is the best model, I feel. People from academics should come to industry, work for some years, and go back to the academics. Similarly, people from industry should go to academics and come back to industry. This is a very good model. People will be benefited a lot. we are really looking for your talk, being a chemical engineer, being an expert in safety and fire for the last many years. Your hazard identification, risk analysis techniques, all those things which you are going to talk today will be very useful to not only for the industry people but the academicians also. Thank you very much for accepting to our request, and we are all very eagerly looking for your sharing of knowledge. This is to you now. Up to you, Professor Madhu.
Thank you, Professor Obi Krishna and Ms. Mom Mitra for this kind introduction. At the very outset, let me thank the Center of Excellence in Safety and Fire Engineering and Analytics, CoE-SEA of IIT Kharagpur for giving me this opportunity. Today, I will be talking about the recent trends in recent trends in safety and sustainability in chemical process industries. I am a chemical engineer with more than 18 years of industrial experience. After spending 18 years in industry, I joined academics way back in the year 2004. So I have seen both the industrial arena as well as the academic field. So I hope I'll be able to share some of my experiences. So let me go to my presentation. Let me share the presentation with you. So this is the topic title of my presentation. Recent trends in safety and sustainability in chemical process plants. So I think there are quite a few chemical engineers in the audience working in process plants. So as all of you know, chemical process industries, they handle, store and process large quantities of hazardous chemicals as well as intermediates. And these hazardous chemicals and intermediates, they have high damage potential because of their inherent nature. So as I pointed out earlier, the substances in storage, usually the process plants, including the petroleum refineries, the petrochemical plants, they all store large inventory of the raw materials, their intermediate products, as well as the finished products. So the substances in storage, as well as the stressful operating conditions, because many of the chemical processes work under high pressure, high temperature, as well as under controlled exothermic reactions. So these conditions pose considerable risk to those working in the industry as well as in the neighboring industries as well as in the neighboring community. So that is the reason for this high risk in chemical process plants. Now, you may be aware about the various disasters that have taken place in chemical process plants over the last more than 100 years. Several incidents have occurred. So if you examine these accidents involving major hazards in chemical process plants, they can be categorized into two. One is loss of containment or leakage of flammable substances, highly flammable substances. Then, of course, when the substance, these flammable substances, they are highly volatile, so they mix with air. Then they may form a flammable vapor cloud, depending on the flammability range and all that. Then that cloud will drift to a source of ignition, and ultimately it will result in a fire or explosion. Usually vapor cloud explosions, blovey, boiling liquid expanding vapor explosions. They are all very common in chemical process plants. So of course, the fire or explosion will affect the site and possibly the populated areas. So this is a typical case of loss of containment. For example, in a petroleum refinery, for that matter, you have large storages of crude petroleum as well as petroleum products. So if there is a loss of containment due to any reason, it can result in such a situation. Then the second category is with respect to toxic substances, leakage of toxic substances from the containment. And of course, these substances also will form a toxic vapor cloud. We have the example of Bhopal, which is considered as the worst industrial disaster that we ever had. So once these toxic substances form a vapor cloud, they will drift in atmosphere. They get transported in atmosphere, and it depends on various factors like the atmospheric conditions, atmospheric stability conditions, then the wind direction, wind speed, and all that. Of course, these clouds will affect directly the site, and also it may travel to populated areas. So this is about a picture of that MIC storage in Bhopal. Anyway, we're not going into the details. Again, so we have, so you know that a number of accidents have taken place in process plants, and if you analyze these accidents, you find that the main causes of these accidents were due to major 4 reasons. Main causes were 4, like, of course, other reasons are also there, but the percentage contribution of these errors are more. Like, one is human error. That is worker failing to follow the safety procedures that have been put into place by the company where he or she works. Human error leads to, anyway, if you examine the history of disasters, chemical disasters, you find that human error is a major factor. Then, of course, improper training. Training plays a major role. That is to educate the operating personnel to operate the equipments in the way it was designed to be used. Equipments are, they should be operated in the way they are designed. And also the operators should also learn to employ correct safety procedures. Here, of course, the supervisors and the top management has a responsibility. Okay. Then the manufacturing defects. Defects in equipments as well as the materials used. That is, I think, another major issue. Then improper maintenance. Lack of regular maintenance at scheduled intervals. That is, again, another major factor that leads to many accidents in process industries. Now, coming back to process safety. Process safety, it can be defined like this. It's a definition given by the Center for Chemical Process Safety of American Institute of Chemical Engineers. It can be considered as the protection of people and property from episodic and catastrophic incidents that may result from unplanned or unexpected deviations. It can happen because any accident occurs due to unexpected deviations or unexpected process conditions as far as a chemical industry is concerned. Now again, before discussing about the recent trends in process safety, I wish to share with you the pillars of process safety. And again, this framework has been formulated by the Center for Chemical Process Safety, CCPS. It's a very important arm of the American Institute of Chemical Engineers. So according to them, there are 4 pillars. They are considered as the foundational blocks of process safety. One is commitment. Commitment on the part of top management. It has to start with the top management. Commitment of the top management, then the middle management, supervisors, and the workers, the operators. Then the second aspect is understanding the hazards and risks. Only if you understand the hazards and risks properly, then only you can address them in an effective manner. The third one is managing the risk. How to manage the risk? Because that risk is, as you know, it is the probability of hazard plus probability of occurrence of the hazard. So you cannot, it may not be possible to eliminate the risk. So you will have to manage the risk properly. In a, of course, as far as an industry is concerned, the risks are to be managed in a cost-effective manner. That is also very important. At the same time, it should be effective. Then the fourth pillar or foundation is learning from experience. That's very important. Learning from experience. Sometimes, anyway, of course, when a disaster occurs, everyone will say we will try to learn from this disaster and try to avoid the occurrence of such errors. But anyway, it's a human nature. It's of course we are all humans, and human beings have a tendency to forget. Then because even in our country, after the Bhopal disaster, a number of changes were made in our legislations. We have very effective legislations. The legislations are comparable with the legislations in the West. So they were all due to the lessons learned from Bhopal. But at times there can be some complacence on the part of all the stakeholders. That has to be taken care of. Then again, there are about 20 elements associated with these 4 pillars. So I will briefly touch upon all these 20 elements. This is the process safety management framework. It is called the risk-based process safety management system proposed by the Center for Chemical Process Safety. So here you can see at the bottom, you can see the 4 pillars and the 20 elements here. So first we will discuss about the elements associated with commitment to process safety. There are 5 elements. Well, first one is process safety culture. So safety culture, anyway, safety culture plays a major role in ensuring safe work practices in any type of industry. For that matter, chemical industry is no different. So there is a need to develop, sustain, and enhance the organization's process safety culture. Also, that process safety culture has to do with the group values as well as the behavioral patterns of the human beings employed in that organization. Then, of course, compliance with standards, because several standards, regulations, and laws are applicable to process safety. There are international codes and regulations. Then you have national legislations and local regulations and standards. So the industry is supposed to follow all these standards in the true spirit. So the standards, they help a company to operate and maintain a safe facility. And also, it will help the company to implement a process safety practice. It is a consistent process safety practice. And also, of course, it will minimize legal liability. These are the advantages of following the standards, codes, and regulations. Then comes process safety competence. Okay. Earlier we talked about the importance of training. Developing and maintaining process safety competence. It is through one is continuous improvement of knowledge, then availability of appropriate information, application of what has been laid, process safety, because availability of appropriate information is also very important. Nowadays, we insist that every process plant has this material safety data sheet, appropriate information. Then, of course, the standard operating procedures, they should be available. So, availability of appropriate information. Then, application of what has been laid. Then comes the workforce enforcement, active participation of the company employees as well as the contractor workers. You cannot avoid the workers of the contractor because they are also working inside the plant. Maybe in earlier days in our country, this was overlooked. The safety aspects of contractor workers was overlooked, but it has changed now. Organizations are taking due care in even training or getting the involvement of these contract workers. So that is important. Then, of course, the stakeholder outreach. It is just to be seeking out to individuals. So you should have a dialogue with the stakeholders regarding the company operations. So the stakeholders may get affected by maybe, of course, in the worst case, a disaster. If a disaster happens, the stakeholders also will get affected. The surrounding community will get affected. So every process industry has to establish a relationship with the community, then with the other companies in the vicinity, then of course with the authorities. That's very important. Because in 1984, when Bhopal disaster happened, it was totally absent because the organization had no relationship with the general public. Even at the time, even under the Factories Act existing at that time, it was not necessary to share the information regarding the hazardous substances that you store, handle, and process. So it was not shared. Even the information regarding the hazardous chemicals handled in the company, in the Union Carbide factory, that led to the higher number of casualties because even the doctors were not aware of the antidotes to be administered. Such things should not happen. So there has to be interaction with the stakeholders. So that is about the first pillar. Then comes the second pillar, that is understanding hazards and risk. That's the second pillar of process safety management. So process knowledge. Anyway, process knowledge, anyway, a process plant will have lot of information, like the technical documents, the process design documents and specifications, then the detailed engineering drawings and calculations, then specifications for design, fabrication, installation of the equipment, all these material which will be available. They are all part of the process safety knowledge. And of course, material safety data sheet. All these material safety data sheet should be readily available for reference. Then, of course, it's a very important activity, hazard identification and risk analysis. And it is a mandatory requirement also in our country. As per the manufacture, storage and import of hazardous chemicals rules of 1989, hazard identification and risk analysis, risk assessment has been made mandatory for a major accident hazard unit handling hazardous chemicals. So even under the Factories Act amendment of Factories Amended Act of 1987, there is a provision for risk assessment. So the identifying hazards and evaluating risk at facilities throughout the life cycle of the plant. That's very important because earlier there was a tendency to restrict this exercise to the just before the installation of the plant, at the design stage and before the commissioning of the plant. So it has to be a continuing activity throughout the life cycle of the plant. You are supposed to carry out hazard identification and risk assessment. And also, we have to make sure that the risk posed by the plant, process plant, is controlled within the risk tolerance level. There are some benchmarks. Anyway, in our country, we don't have a mandatory risk tolerance level. So we follow the risk tolerance level proposed by other agencies. So there are three main risk questions: hazards, what can go wrong, then consequences, then likelihood. Then, of course, this is generally a acceptable risk criteria proposed by the HSC of UK. A risk of death of 1 in 1,000 per annum, 1 into 10 to the power of -3 per annum, is usually considered as an acceptable level of risk. Then comes managing risk. It has 9 elements. First of all, operating procedures, proper development, timely maintenance, and use of operating procedures. Then, of course, safe work practices. Safe work practices are very important for managing the risk. It helps control hazards associated with the maintenance and other non-routine work. Then comes the asset integrity and reliability. It's a very important aspect of risk management. So it is to be ensured that equipments are properly designed, installed in accordance with the specifications, and remains fit for use until they are retained. Then, of course, the contractor management, there has to be a system. Then training and performance assurance, training to enable the workers to meet the performance standards. Then management of change, of course. Management of change, it is the responsibility of the management to ensure that changes to a process do not introduce new hazards or unknowingly increase the risk of existing hazards. So management of change, it's a very important activity. It includes a review and authorization process for evaluating proposed modifications. And the potentially affected personnel, all stakeholders, have to be notified of these changes made in the plan. It's again a lesson learned from Flixborough. I think you're all familiar with the Flixborough disaster of 1974. It is anyway, this disaster occurred in the cyclohexane oxidation section of the caprolactam plant there. So there were 6 reactors. So there was some problem with the 5th reactor. It was taken out for repair. So the 4th and 6th reactors had to be connected. So that connection was provided without the proper engineering analysis and proper approvals and controls. And that led to the later investigations revealed that this error led to Flixborough disaster. So this management of change has significant importance. Then operational readiness, that is safe startup of processes over the life of a facility. Because during startups, there is every possibility of deviations occurring. So it is very important to have a pre-startup safety review, PSSRs. Now every process plant does it. And we know that there were issues during the lockdown period declared after the COVID-19 pandemic. So in fact, we had a very bad experience at the Vizag gas leak of May 2020. Anyway, we don't have much time. So it was anyway that the styrene monomer. It was anyway somehow the cooling system failed. Then that the anyway, that is pointed out anyway that monomer had to be stored between 20 to 22 degrees Celsius, and higher temperatures can result in rapid vaporization. And so the cooling system, there was some problem, and the temperatures exceeded the safe levels, causing the styrene to vaporize and the gas leaked out. Then, of course, conduct of operations, execution of operational and management tasks, then emergency management, of course. Anyway, in spite of all the precautions that we take, we should have a very efficient emergency management plan. Again, in our country also, it is mandatory. You have to plan for on-site and off-site emergencies. Of course, the on-site, off-site preparation of the off-site plan is the responsibility of the district administration. Then the fourth element, learning from experience. So again, incident investigation. Whenever an incident occurs, there has to be a formal process for investigating the incidents, and the investigation data and the trending of the incident, it should enable the organization to identify recurring incidents and to take precautions to prevent them. That's very important. Then, of course, measurement matrices, it is for performance and efficiency assessment. Then auditing like safety audits and other auditing procedures, management review, inspection. Then, of course, the management review and continuous improvement. Any management system, there has to be a provision for continuous improvement. In some management system, they call it a continual improvement, a gradual, step-by-step improvement. So these are the pillars of process safety. Now let's talk about the recent trends in hazard identification and risk assessment, risk analysis. It is part of the second pillar, that is understanding the hazards and risk. Second part of second pillar, hazard identification and risk analysis. Now, a lot of work has been done during the last 40 years or so. In fact, the whole exercise started after the Flixborough disaster. After the Flixborough disaster, it was really an eye-opener for the Western world, the European countries, and they started formulating procedures for the identification of hazards as well as assessment of risk. So now we have several large, it's a long list of hazard identification techniques like inventory analysis, then Dow Fire and Explosion Index, MOND Index, what if analysis, hazard and operability study. Hazard and operability study, again, incidentally, it was developed in the United Kingdom, again by the ICI, Imperial Chemical Industries, in the 1970s. Again, that great safety guru, Trevor Klutz, he was part of that exercise. Then the failure modes effect analysis, failure modes effects and criticality analysis. Then even hazard and operability study is very popular in chemical process industries. And now, again, whenever there are changes, whenever changes are made in the plant, HACCP studies are carried out in process plants. Then, of course, the techniques like fault tree analysis, event tree analysis, they are helpful, they are useful in estimating the frequency of occurrence of the hazard or probability of occurrence. And the bow tie analysis, it's a linking the fault tree and event tree. You can have a bow tie with the barriers in between. It's a very useful exercise. Then, of course, several techniques have been developed over the years, and they are used by the process industries, hazard identification. And usually, when a risk assessment report is prepared, some of these techniques are employed to identify the hazards. Then, of course, now, we can think about the LOPA, layer of protection analysis, then safety, integrity, functional safety, safety assessment of safety integrity level of the instruments. Now, because the process instrumentation and control plays a major role in preventing or maintaining the process parameters. So the integrity level of instruments is assessed. So many techniques have been developed. Now that is the first part of risk assessment. Then comes the quantitative risk assessment. So quantitative risk assessment, we differentiate between the hazard and the risk. A hazard is anything, the property of a substance or situation, the potential for creating damage. Then the risk is the likelihood of a specific effect within a specified period. So it is a complex function of risk, is a complex function of probability. Then the consequences of the event, it may be a fire, it may be an explosion, it may be a toxic gas dispersion. Then of course the vulnerability. These three parameters, factors are considered when we compute the risk. So you usually identify the hazards in risk assessment, then quantify the risk, then determine components or safety measures, component safety measures, and the units or sections where human interventions are important for process safety. Sometimes we try to prioritize the risk available in the plant, risks posed by the different sections of the plant, because the risk posed may not be the same, because some sections of the plant may have a high risk potential. So you can prioritize the risk with the available, with the information, with the techniques available with us. You cannot say that these techniques are all foolproof. They have been developed over the years, and of course, there is scope for improvement always. So we try to quantify the risk. Then this is a framework for QRA. Hazard identification, then analyze the accident scenarios, estimation of accident frequencies using fault tree, event tree analysis, then consequence analysis and modeling, and ultimately and finally, we carry out the risk estimation. Again, this is another, so in hazard, we consider hazard and scenario analysis, we consider the likelihood and consequences. Then consequence assessment is used to, it's an integral part of any risk assessment activity. It is used to determine the distance to which casualties or damage may occur as a consequence of an accident. That's what we do in consequence assessment. So the conditional probability of loss of life or damage as a consequence of an accident, that will be assessed in the consequence assessment. We make use of empirical and semi-empirical equations for consequence assessment. Now, very useful softwares are available in the market. Softwares like FAST, Safety, etc. are widely used by the process consultants who carry out risk assessment studies. So, consequence assessment. So, this is a typical consequence assessment for a flammable, for the instantaneous relief or the release of a flammable pressure liquefied gas. So here, of course, anyway, you have to estimate the discharge rate. So anyway, you have to assess the tank rupture. Then the various scenarios you have to visualize and make the calculations for the different consequences like fire, explosion, and dispersion. Then coming to risk, there are two ways to classify the process risk. You have individual risk as well as societal risk. Individual risk is it's a sort of it's a hypothetical concept. Is some specified event to a person, hypothetical person, assumed to have representative characteristics. Again, some assumptions are made. assumes no protective action is taken, typically assumes recipient is outside 24 hours per day and all that. Then, of course, the societal risk. Societal risk takes into account the actual population present, and usually we make a FN plot. It shows the frequency of accidents involving N or more of fatalities, and it can be represented as a single number. Earlier you had seen that 1 into 10 to the power of -3 fatalities per year, average rate of death. Then, so it can be modified to show financial risk also. So the QRA methodology is once again summarized here. Now, so till the early part of the 21st century, we were industries and consultants were carrying out the conventional QRA exercises, conventional quantitative risk assessment. So it has a disadvantage. Conventional QRA considers only the major accidents or incidents. So there was a tendency to ignore abnormal events like incipient faults, near misses, and also new knowledge and variations in the system. So these categories, these items used to be ignored in the conventional QRA. So by 2006, the concept of dynamic risk assessment methodology emerged. It was developed by these two safety specialists, Beal and Seider. So their approach aimed at estimating the dynamic probabilities of accident sequences, including near misses and incident data, as well as real-time data from process. So they tried to make use of the data related to near misses, incident data, and as well as real-time, and also made use of real-time data from processes. So this is again a summary of the various dynamic methodologies, several methodologies. Now the middle one, the dynamic risk assessment methodology, it is the most popular one. So here, monitoring and report of process incidents and near misses, these are the steps. So it involves scenario identification. Then they call it prior function calculation. Prior function calculation. Then formation of the likelihood function. Then there is a posterior function calculation, and then consequence analysis. And of course, the statistical concept of or the statistical technique of Bayesian network is widely used in this dynamic risk assessment, which was developed during 2009. It was the first paper was published in the year 2009. So this dynamic risk assessment approach integrates Bayesian failure mechanisms with consequence assessment, integrating Bayesian failure mechanism. So it has. So if you make a comparison with the conventional QRA, you find that there are two additional steps in dynamic risk assessment. One is accident analysis, and the second one is probability updating. That's what in the earlier slide you have seen this prior and posterior functions. That is for probability update. Now, as a whole, that QRA exercise, as I told you earlier, it started in the 1970s. And of course, anyway, it was introduced in our country towards the second half of 1980s after the Bhopal disaster. So it has its own advantages, even including dynamic risk assessment. It has its own advantages. So it's a good basis for consistent decisions. That is very important. That's a great advantage when different types of hazards have to be considered. Then it can be used to analyze the various contributors to an overall risk as a basis for determining the major contributors. That is for prioritizing the contributors. Then it's a useful way of demonstrating that certain events are unlikely to occur. That is also there. So we need not spend time on these events. That is also there. But it has its own drawbacks also. QRA technique, even dynamic risk assessment also has, anyway QRA has, the earlier conventional QRA had disadvantages, but that uncertainty element has been addressed to some extent in dynamic risk assessment, but still it is a complex analysis. QRA is a complex analysis. It's usually a compute-aided, we make use of softwares. So generally it can lack transparency. That's a drawback. Then there is a danger of we estimate probability values. For estimating probability, of course, to address the issue of uncertainty, we have adopted different techniques over the years. Large number of research papers have been published during the last 15 years or so, applying the various mathematical and numerical techniques. When soft computing techniques have been used for to remove the uncertainty in the estimates. But still, there is a danger of overconfidence in the estimates of probability. So then there may not be sufficient data available for a particular case, because this probability, usually we in Bayesian, for example, Bayesian network, or in fuzzy logic, we have fuzzy techniques, different types of fuzzy techniques used. They're all, you make use of expert elicitation, expert judgment. So there are possibilities of error in even in expert judgment, because they may overlook the incidents that are very rare in nature. There is that danger is there. Then assumptions are usually made. Of course, in the development of consequence analysis models, a lot of assumptions have been made to make calculations easier, and sometimes the limitations can be overlooked. So now people are talking about alternatives to quantitative risk assessment. It's a useful technique, but we cannot give undo. We cannot depend only on QR. Again, though a lot of research has been done on dynamic risk assessment, the industry generally, the industry is not really impressed by these developments, how it can be extended to risk assessment. So now some organizations have started doing it, but now a group of experts, they have come out with the alternatives to QR, because still a lot of uncertainties are there, and these uncertainties and some of the cases may be overlooked, and there are unknown threats, black swan events and all that. So to protect against these upsetting threats, of course, we can take measures up to a certain limit. So now a group of process safety specialists are talking about resilience assessment. They call it resilience assessment of process plants. Resilience is defined as the ability of the plant to restore performance after sustaining serious damage by an unexpected threat. Anyway, the concept is still developing. The Mary Kay O'Connor Process Safety Center at Texas A&M University, they have started working on this resilience assessment. And this resilience assessment, it is based on 6 principles: flexibility, controllability, early detection, minimization of failure, limitation of effects, administrative controls, procedures. Then there are 5 main factors contributing to resilience. So all these factors, so these researchers, they have tried to develop methodologies for resilience assessment, taking into account design, detection potential, emergency response plan, human factors, and safety management. So that's about the recent trends in hazard identification and risk assessment. Now, of course, the title of my talk is recent trends in safety and sustainability. Now, of course, process safety, process industry. Now, the process industry is giving a lot of importance to sustainability. And as you know, there are three pillars of sustainable outcomes. One is environment, then economy, and the social sphere. Usually, more attention is given to improvements in the environmental outcomes, right? Like resource usage, emission reductions, because now everyone talks about reducing the carbon emission. So, a lot of attention is focused on environmental outcomes, whereas the aspects like occupational safety and health, it is usually classified under the social sphere of sustainability. So it gets less attention compared to the environmental component. So there is a need to give more attention to this area when we think about sustainable outcomes. So anyway, of course, the process industry has initiated several strategies, made several initiatives for ensuring sustainability, like adoption of inherently safer processes, process intensification, then cleaner production strategies, pollution prevention and waste minimization, then of course reduction in greenhouse gas emissions, and transition to circular economy, where we try to make use of the waste generated. So all these strategies can contribute to the environmental sustainability of chemical process industries. So there is a need to ensure safety as well as sustainability of the process plants, because we have to see that the human life is precious and it has to be protected. So safety specialists, process safety should be given its due importance, and along with that, we have to ensure environmental sustainability. And sometimes they are related to each other. Safety and sustainability are related to each other, because a major safety problem can affect the environmental sustainability of the process industry. So we have to give equal importance to these concepts, the concept of the practice of safety as well as practice of sustainability in the coming years. So with this, let me wind up my lecture. Thank you very much for your patience here.
Thank you, sir. Thanks a lot.
Thank you.
Very, very holistic overview of the PSM management. Sir, I would request now Ashish to take over for the further Q&A. We can see many questions in the chat box.
Yeah. So thank you, ma'am. Thank you, sir, for this nice talk. We have many questions in the chat box. I'll take one by one.
Yes.
The first question for today's session is, for MOC elements change, who should be involved for authorization and how it can be really established in a sustainable manner?
Yeah. So will you please repeat this question?
Yes, sir.
Yeah.
For MOC elements change, who should be involved for authorization?
Yeah.
And how it can really be established in a sustainable manner?
Yes. So management of change, anyway, all the various levels in the management has a responsibility. It starts with the top management. So the top management should have the commitment towards implementing this management of change strategy. So they should formulate a suitable procedure with a responsibility for authorization and controls, and that way. So if you can implement that particular procedure, that procedure has to be very well written down, and it should be followed in letter and spirit. That way we can ensure that this strategy is implemented in a sustainable manner. Hope I have answered your query.
Yes, sir. Thank you, sir. So the next question is, do the resilience assessment can ensure the total sustainability and changes in an industry?
We cannot say that it will address all the sustainability and safety problems in the industry, because these are all emerging techniques. But to a great extent, I feel it can take care of the sustainability of chemical process plants. Of course, anyway, we need not do away completely, do away with the with this quantitative hazard identification and quantitative risk assessment. And you can carry out a resilience assessment also. But anyway, it's at the developmental stage. Anyway, the methodology is yet to be finalized. So, of course, in future, we can think of adopting resilience assessment as it can even be made a mandatory requirement, maybe after a decade or so.
Yes, sir. Thank you. So our next question is, what is incipient faults in conventional risk assessment?
Yeah. So in conventional risk assessment, the inherent what we call the inherent errors that can occur in the plant, that may be overlooked in conventional risk assessment. There is a tendency so to overlook these inherent errors that can be made in the plant. So they used to be overlooked in conventional risk assessment, whereas the dynamic risk assessment addresses these inherent errors. That way it is addressed.
Yes, sir. Thank you, sir. Our next question is, how can analytics help in predicting process accidents in chemical plants?
Yeah. So analytics. So if you have a large database, you should have a proper database of the accidents taking place in process plant. That statistical the statistical data can be very effectively analyzed using these analytical techniques. That is very quite possible, and it will give very useful trends. This application of safety analytical techniques to the past data will give you valuable clues regarding the trends of accidents. That way, it will be very useful.
Thank you, sir. So now I'll take the last question for today's session. Yes, so this has been seen in various accidents that codes present at that time did not have the details about a particular case, like you told in 1984 Bhopal tragedy. Sharing details with general people was not there. So how can we make our standards more efficient?
Yes. So there is a need for constantly updating our standards, rules, and legislations. Now attempts are made, but there is a need. Even industry can contribute a lot to that. So now anyway, the industry is also taken into confidence while standards, codes, and legislations are made. So the industries can give the valuable inputs to the regulators regarding the formulation of these standards or updating the standards and legislations. That way, I think we can address this problem.
Yes, thank you, sir, for answering the questions of the participants. Now, I would request Professor Menon to formally provide vote of thanks to our today's expert speaker, Professor Menon.
Thank you.
Yes, sir. Yes.
Audible to you? Yes. So I'm sorry I cannot switch on my video because of weak internet connectivity here. So thank you very much to Ashish for entrusting me to deliver this vote of thanks today. So regarding Professor Madhu, I would like to have few words. Otherwise, I feel this will be incomplete. My association with Professor Madhu has started since 2007, and we made a very good work in those days in application of system sciences in safety engineering and management. And perhaps that work we did from 2007 to 2013 was one of the was the first work in this area in safety engineering in the whole state of Kerala. So we also got international publications and international conferences out of this work. And presently we are still collaborated in modeling for natural gas industry, which is a project from Government of India. So it was nice, sir, to listen to you after a very, very long time. And I extend my sincere thanks to you, Professor Madhu, for his very informative and insightful talk today on the subject matter we have discussed. And I also sincerely expect that we will be able to do more collaborations in the near future regarding not only research, but also regarding this academic information sharing with our Center of Excellence. So on behalf of Center of Excellence in Safety Engineering and TAKES and IIT Kharagpur and all the participants, I once again extend my sincere thanks to Professor Madhu for spending some time with us out of his very busy schedule. I know what his schedule is in CoE-SEA and delivering this very wonderful talk. Thank you very much, sir. Thank you. Have a very nice day.
Thank you very much, Professor Balagopal, for this opportunity and for the kind words. Thank you very much.
Thank you, sir. Thank you.
Thank you, sir. Thank you, sir. Thank you.
So, thank you. Shall I leave? Yes.
Yes,
So,
sir, yeah.
Shovik, we can conclude the meeting, I guess. Is it?
Yes, sir. Yes, sir. We can conclude the meeting, sir.
Okay. Thank you to each and every participants in this presentation today. Thank you. We will meet in the next week. Thank you very much.